Hello everyone, welcome to the Developers and Coders Club of NIT. Today we have a question table which, which is of A to OG ladder. Here we have given a guy with the name Simon who has a rectangle table with n rows and m columns, and the table corners are the cells we have provided with our the coordinates with 1 comma 1 n comma 1 and 1 comma m and n comma m are. Simon thinks that some cells in this table are good. Then what actually the good cells are? It's decided that no good cell lies in the corner of the table. Suppose here we have the table of n rows and m columns. So no good cell lies in the corner of the table. As for example, this one, this one, this one, this one. These cells won't be a good cells. So initially all cells of the table are colorless we have given, and Simon wants to color all the cells. In one move, he chooses any good cell of the table. X1 and Y1 are the coordinates of the table, are the cell coordinates of the table with n rows and m columns. So he wants to color the table. So we have to given the output with how many actually the minimum numbers of operations that he has to be executed to color all the cells, and we have given the condition that one cell can be colored multiple times. So let's proceed how to its approach, how it will be done. In the test cases, we have table with 3 rows and 3 columns. So here let's make it. And the entries with the cells taken inside it are 0, 0, 0, 0, 1, 0, again 0, 0, 0. So we have to given the output that how many minimum number of operations that can be executed to color the entire table. So we have already given the constraint that in the corner of the cells would be the good choice of the table to get colored to start with. So here the cell located at 2, 2 we consider as a good choice. So let's start coloring the table from this part. This will be the first operation to color the table. Now let's change the color. This is the first operation. Then again taking 2, 2 cell as the good choice, we can take the upper part to color it. Second operation. Then moving further, this portion will be the third operation to color the table. And in the last, change the final color finally. This part, fourth operation. And in the fourth operation, we will find out that the entire table has been colored. So the output, so the minimum number of operations that can be executed to color the entire table of rows and columns 3, 3 are 4. Now in the second test case, we have given 4 rows and 3 columns. So let's make it 4 rows, 1, 2, 3, and 4. And columns we have 1, 2, and 3. So again, the entries which the cells of the table are taken are 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, and 0. Again, the constraint that we have given is the corner of the cell won't be a good choice. So This time we will take 2 comma 3 as our good choice of the cell. Now taken this as a good choice. Here is the first operation that we can carry out to color the table. This and further move on, we can take the good choice of the cell located at 3 comma 1. Now taken this, the lower part of the table get colored, and by carrying out two operations, entire table of 4 comma 3 will get colored. So here is the output. Let's move on its code. Here is the code of table of A2OG ladder. Here we can clearly see that we initialize a variable n m a. N and m are the rows and the columns. A basically is the input that we have taken to account to taken on a count bill. Then we initialize a bool operation is to taken as 0. Then we taken an input of 2D matrix which is of table. Then we implement if loop, if condition, if a equals a, then the index of a equals 0 or index I is equals to n minus 1, then is2 of bool become 1. Similarly, j part will become equal 0 or j part will become m minus 1, then is2 will eventually lead to 1. Now again on applying if is 2, then we get the output of operations as 2.